Yeah, so in today's call, I wanted to drill a little bit more into the contribution of the interconnect and how we shape that, which is what I put in the email. Does that make sense?
Sure, yeah. Okay. Thank you. Thank you for updating.
And from Samsung's perspective, you said Samsung would be happy to be involved. Have you got any more clarity on that at your end, or not? Into what sort of capacity?
Right now, I'm gathering information from this what you just mentioned, and then based on that, I think I need to work with my internal team. So that's where I am right now. So
okay. Well, once I get the basic framework together, I think Samsung can participate in various areas, right? And so maybe if you got your right people, we could talk to them on specifics if you like.
okay, yeah, okay.
Yeah. So in terms of the agenda today, really, as I said in the email, so apologies for the short notice, guys, and thanks for managing to attend. In fact, I think we got a response from Z from Amphenol saying that he had a clash today, and I think he might have an ongoing clash. So again, before we end, let's try and see if we can maybe get a date that can work for all you guys, and we see if we can move it maybe from today. But okay, so yeah, so I was just going to bring up the presentation that we've gone through a couple of times. So on our last call, that was a while ago now. Let me just share the screen. Okay. So on the last call, we were talking about there's two main efforts that we need to get underway on the EDSFF connectors where the E3 drives plug in. We were talking about fundamentally we need to make those surface mounted. So I think that's a relatively easy task. I guess we'll have to work with SNIA in some sort of way, but so one of I think that would be maybe in the proposal, the funding to do that, and which interconnect company would put themselves forward for doing that piece. But our bigger discussion that we had on the last call was the getting a new interconnect, which I'm beginning to call a universal interconnect for topologies, for wiring these modules together for the cabling. And the last call, if you remember, we were discussing the MCIO, the paddle card connectors, which we're using for PCI and CXL, which is currently at 32 gig and moving towards 64 gig on PCI Gen 6, as compared to the Ethernet miniature connectors from the likes of Samtec and Molex, where they don't use paddle cards. They literally solder these twin-ax cables straight onto the metal pins and in the cable, and that gives a better, cleaner signal integrity instead of going through a paddle card. And there we're talking 112 gig moving maybe up towards 224 with these types of connectors. Now, the problem with these ones, they support the higher speed, which I think is essential. We want to be able to do at least 112 gig Ethernet with these cables. So arguably the paddle cord format wouldn't work, but we had a good discussion around that. and I guess everybody, including I think Matt from Samtec was on, that provides this direct cable attach. We had the Amphenol chap, Z, he was on, and basically they felt that basically we could, even with a paddle card, you could get to 112 gig. So assuming, so they're the experts. So if that is the case, rather than completely reinvent the world, I was thinking that we could standardize on this MCIO connector. But the key thing here, because this is obviously in production, but we need to reassign the pins for our need, because we were talking about different, using LTPI as a sideband aggregator, and so that this was a proposed pin out where we would need fewer pins, and we could allocate some of the pins to power and still be in this quite small connector format. So I was wondering if we actually took this approach where we had one connector, and this would be like a topology interconnect for between HPCM cards. But as well as that, we would specify this connector so that it could use passive cable. It could, so it's one design for all. And again, we've got this impedance mismatch between Ethernet and PCI, which is a pain in the butt, and people use these mid-range impedances on the connectors, if that's going to be good enough. But we have this one connector, one cable, and obviously, depending on the silicon that you solder down, the protocol across these topology cables could be Ethernet, could be CXL, PCIe, or it could be NVLink or Infinity Fabric or whatever proprietary ones as well, if there were proprietary links between these I/O. And we would also support active optics on here, or active electrical as well. So we could put repeaters, retimers, redrivers, whatever inside the on the paddle card. And the idea here would be that so this is replacing, if you like, the likes of the QSFP and the OSFP into a much more miniature format, which hopefully the promise of silicon photonics will get us there. And or other, there's a LED technology from Avicenna as well, who were on the last call. And so you've got that, you've got low energy, where maybe each end of these will be burning about 5 watts, and then we need to introduce the thermal mechanism for actually conductively cooling the active end of the cable on the manifold. Okay, so basically, I was thinking that would be a program in itself to make this what I call this universal topology interconnect, which we could drive, but to keep the costs relatively low, if we base it on the PCI, CXL, MCIO mechanical, we'd probably put an extra key in there so that only our cables would plug into this, even though it's based on the same format, because it's going to have power on there, obviously, and take that forward. As well, I was thinking as we go towards silicon photonics and or LED optics, where it might, when we get to, I don't think we'll ever need to bother doing a 224 gig twin axe electrical. I think that potentially it's going to make more sense to actually quickly get ourselves into the optic world. And so I want to be able to build active optical cables. But as well as that, the final thing in the thinking is that we'd also put some optical, we could use the same connector and maybe put some holes, if you like, in the bottom of the middle of the connectors, where light could come from co-packaged optics configurations on the actual module itself. So, and maybe, so the way I was thinking about this is you could put an active optical cable So in fact, Light Intelligence is on. They demoed it at one of the shows last year. I think it was supercomputing and maybe FMS. That they had an optical PCIe cable. It was multiple fibers. I think they had 16 fibers or something like that, but it was a tiny little device. And so we could potentially, and I think they were talking about, or they did show it packaged in something like the MCIO, so that we could actually make a light intelligence cable on that based on what they've been doing. Avicena have their LED optics. We could do an active optical cable there, so we can do the sort of CXL speeds. And actually, Avicena are also doing an Ethernet QSFP cable, so potentially they could miniaturize what they've done in there because their components are so small that we can do that and make an active optical cable of that. So that would give us optical versions of today's CXL and PCIe, but also we could start to investigate the co-packaged optics, and maybe we could bring multiple optical, like Avicena talk about a terabit per second per fiber or per two fibers, and it only takes up about it's about a millimeter per fiber, I think. So it's about a 5 millimeter of space. So these are like 30 millimeters long. So potentially you could have 4 terabit links in one of these connectors. So you could actually, in the same mechanical format, you could make a passive optical cable with the active optics on the board. So the idea here is that we've got this sort of this universal interconnect that can take us from today's high-speed links to tomorrow's co-packaged extremely high-speed links, but in a more graceful way in this trying to revolutionize overnight, and that might make more sense, both cost-wise for depending on the chip that goes on the HPCM module. It might be a chip with not a lot of I/O bandwidth, and therefore the old-fashioned approach and lower cost approach is better. Or you might have a chip that has a chiplet implementation that has 2 or 4 or 8 terabytes per second of I/O, and you need co-packaged optics for that to work, and you can implement that. But essentially, it's the same mechanical universal interconnect that we're using. So that's the vision of, and I think this is where the bulk of any funding from this new frontiers would come. And I think this would also be a nice story of showing how this module format can take us from today and work with today's technology, but also take us in a migrationary fashion to tomorrow's co-packaged optics I/O with dramatic speed increases. I've said a lot there. Did all that make sense? Any questions? Any concerns?
Hi, everyone. This is Bobby from Light Intelligence, and this is my first time joining this group discussion.
Yeah, hey, Bobby.
Thanks. I was wondering, like, what it, because I missed a little bit part due to the audio problem, so I couldn't get the benefit between using the MCIO versus what is the benefit of using the SAMTAC connector compared with the MCIO? Because I know MCIO has been like low cost and it's been existing for a while. But what is the main benefit of using the SAMTAC connector?
Sorry, I was basically saying we would use the MCIO, but we would modify it slightly.
Yeah,
I'm not proposing that we would use the SAMTAC. These were ones that we initially discussed at the beginning. This was the first meeting of the interconnect, and the key thing about SAMTAC's Accelerate and also Molex's NearStack is that they actually solder the twin-ax cables straight onto the electrical pins. There is no paddle card. So that gives them a cleaner signal integrity path. whereas the MCIO is the older format of using a paddle card. Now, but the MCIO is only rated today at 32 gig NRZ going to 64 gig PAM4 for PCI 5 and 6. But having discussed this, Samtec were on the call with the interconnect experts. Everyone agreed that the paddle card approach could still work, and we need a paddle card if we're going to put active components on there, like the Lightelligence one. You've already done a Lightelligence one, but MCIO sadly doesn't support power, so they're making a bigger connector in PCI SIG to support power. But that's sort of for remote power operations as well. And if you follow PCI SIG for decades, the previous generation was Molex's near stack, and it was called OcuLink was the name. O for optical and CU for copper, OcuLink. But sadly, no one ever did an optical version, and that did have power. And for some reason, when they brought MCIO to the table, they decided to drop the optical just when we're ready to put optical in these damn things. So shame on Amphenol when they did introduce it. They managed to make progress in PCI SIG with this one, but now we're retrofitting power and we're making these connectors bigger. The other problem with the PCI world is you've got a ton of sidebands, and that's a hell of a lot of legacy stuff as well, which is really from the 70s and 80s, would you believe? Where in OCP we've got this thing called LTPI, so it's LVS tunneling protocol. So you basically packetize the sideband signals over one differential pair. The interconnect companies like using only differential pairs rather than these single-ended. It's actually easier for their manufacturing processes. So we've simplified the I/O down to about 66. There you go. It says at the bottom here, 66 pins. Whoops. So what I'm proposing we do is we use the MCIO connector because it's got the paddle card, and we can put your active optics or somebody else's active optics or active copper retimers, etc., inside this connector. But because we're saving pins, we can allocate the leftover pins to the power to power the active components. Does that make sense?
Yeah, totally.
All right, and I was speaking with your guys on basically doing this, and they said you can't use this connector because there's no power on it, which they're absolutely right. And so that's what we're trying to address here, is to bring, and so I like the idea of using MCIO because we don't have to pay to reinvent a connector altogether. It's already been specified in PCI SIG, so we just need to do some mechanical changes for keying, maybe to make sure the wrong cables don't get plugged in, and for this new conductively cooled thermal cooling, so we can miniaturize everything, and we don't need these ginormous QSFP or OSFP cages to cool it, the active cables.
Agree. I think it's a great idea.
Okay, perfect. And now, Bobby, if we met and spoke before or not?
I don't know. I was in Supercompute and we made, but I couldn't remember.
All right.
Like,
No, I've spoken to a number of you guys in the past, and when you were showing off what you've done with the with the PCI, I said, well, this would be great to shrink into this. So if you guys are interested in participating in this proposal, then I'd be happy to have you.
No, of course, yeah.
Yeah, and then there's the co-packaged optics piece, and I'm not sure how that well. The co-packaged optics one is a little bit more. We're saying we need to bring I/O. I've done previous presentations around the board has all the interconnect is on the back side of the board, and all of the silicon is on the front side of the board. And so if you had active optics, co-packaged optics on the top, at the moment, all of everybody's co-packaged optics solutions, the I/O either comes out the side, the optical I/O comes out the side or out out the top of the devices. And I asked the question is, why can't the I/O, the optics come out the bottom of the devices? And I was told at supercomputing in a panel session that there's no reason why it couldn't, because if it came out the bottom, we could drill a hole in the PCB, and assuming you can do the optics alignment, you could bring it through this same interconnect path. And then you wouldn't obstruct all of the cooling and power infrastructure with fibers flying all over the place. But that probably needs a lot of work, because it doesn't appear that any silicon photonics startup is interested in bringing I/O out the bottom at the moment. So, and I'm not sure that the New Frontiers funding would justify the probably tens of millions for one of you to do it. So, but then that is another area so how do we migrate to co-packaged optics? Does that make sense?
Yeah. I think co-packaged optics is it's still a long way to go, you know, because it's more custom. It has to be customized to like all the different applications, different pin layouts. To bring it out from the bottom, I think it's possible to do it. It's more the challenge is more about like the loss and in reliability, like easy to test. All other things has to be integrated together. So that's why it's more problem need to solve to bring it on the bottom,
Right.
and that's why no one do it right now. But I don't see there's a definitely no in here. So
Yeah, I guess I was chatting to one of the professors from the University of Columbia, Karen Bergman. She's with
oh yeah,
Escape Photonics, I think. She was on the panel and she said there's no reason to come out the other side. I guess nobody's asked for it before. It's more seems to be more of the thing than but to your point, it's always, there are still various problems to overcome. And so that's why I'm saying if we can do something universal where we can say, let's look at the whole transition from copper to optical, active copper, active optical, and then co-packaged. And then if we've got one solution, we can do that migration as and when the technology is ready, without having to completely change everything when the technology is ready, which I think is what's happening. If you look at AR Labs and Intel's demo, you know, they've got a nice demo, but there's a bunch of manufacturing challenges, and then you've got these fibers flying around where you want liquid to be cooling these devices or big heat sinks, and it's a manufacturing nightmare, right? So I'm trying to system thinking ahead of all of this.
Right. You're totally right about that.
So well, I guess so the reason for this discussion is we need to get going on this proposal. When the RFP lands, the final one lands, we've got probably 4 to a maximum of 6 weeks to respond. And so I'm basically doing the rounds of I'm going to try and get this week, get a shell of the proposal together and have placeholders, one of which will be for interconnect. And I want the interconnect companies or the participants, participating companies on the interconnect side or related. There is a bridge with the thermal here as well, to actually put some words in the proposal along the lines of what we're saying. So I think the way it would work, like with yourself, Bobby, is we'd need an Amphenol, a TE, or a Samtec. Matt Burns confirmed on the last main call from Samtec that they would be willing to participate in putting the proposal together, and offering some of the work there. And I believe that Amphenol will be as well. They've been pretty active in the last couple of meetings. But then it would be like, how, can we work you guys with them on like a paddle card design for an active cable? So integrating, which is what you're already doing, I believe, with what you showed at supercomputing.
Yep.
So it would be a case of, would you would you like to package your technology into this format if the funding was there, and if you put any contribute to the proposal on that part of it.
I think it sounds great. I'll present the idea into our higher management about this. I think they would definitely be very interested.
Okay, I did speak to Mo about it, sort of briefly, and a few other colleagues about 6 months ago. But I guess you had a lot of things going on, so okay.
Yeah, that's wonderful.
Okay, that's great. Hi, Hisham, I just see that you've just joined us.
Yes. How are you, Alan?
I'm good. Just put you in here. So yeah, I think this cable is going to be the bulk of the effort needed. We've got this thermal. One of my concerns here is we've got this thermal interconnect. How do we thermally attach this? And I will, in the proposal, Boyd have expressed an interest in helping us out with this proposal, which would be great. I spoke to their CTO, but you know, they haven't finally confirmed. But if they do the thermal side, then the thermal attached there will be the thermal side of this attaching to cool these active cables and or cool the E3 modules. But the interconnect design will need to be such that we have a conductive path from the paddle card this thermal mating as you plug in to the cooling shaft to the manifold here, which has got water flowing through it. So that one is where we're going to need to have a collaboration between those two disciplines. So that's how we put that in the proposal. I think, you know, I guess the connector with the active interconnect in mind on the active version of the cables. So, and then we just need a discussion between both sides as to what is the best thermal mating approach between the two pieces. Now, so in terms of interconnect companies, electrical interconnect companies, ACES makes interconnect, is that right?
We do, yeah.
And so do you do the MCIO ones?
We do, yeah. Yep.
Okay. So is this something that you think your company, well, first of all, are you a US based company or do you have a US entity?
Well, I'm based in the US, yeah. I mean, we're able to build, build concepts and stuff, same thing as like Samtech or whatever. But for like tooling and things like that would be, something we'd have to get, approvals and things like that for.
Right, but do you have a manufacturing sort of, and is it just sales or support in the US, or do you actually have a separate business here?
Yeah, I mean, it's all engineering here, all the real.
Oh, okay, all right. And so if you read the RFP, it talks about only US entities or companies that have US subsidiaries will be allowed to participate. So that's the only thing I was conscious of.
Yeah,
so,
I mean, it's a Taiwanese company, but we have a US, base because they bought the company Genesis. So we have kind of a twofold.
okay. Okay, so it sounds like you'll probably qualify then.
Yeah.
So that's good. If you think your company would be interested in driving this, if we can get the funding, then, and you said you do make an MCIO at the moment, is that correct?
Yeah, we do EDSFF, Gen Z, E3, all that stuff. So.
And the MCIO one, which is a sort of a variation of the EDSFF.
Yeah. We build the connectors, the cables, all that.
Okay. Okay. Well, so I guess if we get an oversubscription of all you guys wanting to do this, my thinking on this is obviously MCIO was brought to market by Amphenol, and they have given. I'm not sure if I think you were on the previous calls where Z gave a little bit of a presentation of what they potentially could do. So they potentially might want to help out on this. I mean, basically, I'd love everybody to help out. Obviously, we want to make this a standard that everybody can make. And it's better for us all to work together in making this a reality. So if we can divide the work up some way, that would be great. But if it doesn't make sense, it's all being done in the open anyway. Is the idea that this can be adopted at some point by everyone else.
Is the optical like a requirement, or is it just a nice?
Oh no, so yeah, I want to make this universal. That's the idea, is we start from the MCIO and we end up with a universal connector taking everything into account, from supporting all different protocols in all the speeds, from all the high speeds anyway, from 10 gigabit upwards sort of thing, 10 gigabit ideally to 224 gigabit at the electrical interface.
Yeah.
And then we can have active copper, if that makes sense, chiplet type devices, and active optical and then if we can get a couple of participants on the optical side, like if we can get Lightelligence and Avicenna, that have been the most active discussions I've been in with, then that would be great. And maybe what we can do is we can actually build some active cables with the thermal cooling and as part of the POC.
Right.
So there would be a collaboration amongst companies anyway. It's just obviously we don't need everybody doing the same thing multiple times.
Yeah, I mean, I think I kind of mentioned it to you last time. It's usually when the grandfather of the connector usually is the one who plays the most active role in this, right? So
I guess along those lines, that would be Amphenol based on MCIO, right? If I remember correctly.
Right.
And also I think is on that side of things, in talking to Samtec, I don't think they even have an MCIO in their family, so they'll be starting from scratch on this piece. Although Matt is offered, Samtec are willing to participate. I'm not sure if it will make sense on the basis they don't have MCIO, but that I don't know, that they might offer still. And then we've got the standard EDSFF connectors, just getting rid of the through hole stuff, and adding and making cables again. The cable format of the EDSFF connectors would need to be the shells, if nothing else, would need to be modified even on the passive ones to fit in our manifold and or provide this active cooling on those as well.
Right. Yeah, I think for the most part, it's a lot of just shape and go kind of thing, but to actually add some of the optical stuff or whatever, maybe it might require additional changes that Amphenol basically requires as far as the standard goes, that they would have to have.
Yeah, so I'm sort of thinking that the shell made by the interconnect companies would come in sort of two forms, either a plastic shell for a passive cable completely enclosed, or the same plastic shell would have a cutout in it, assuming there is a heat sink, and we would architect the heat sink design so that it would fit into the cutout nicely, and it would sit on, and that heat sink would need to be shaped to sit on the active components by a collaboration between the optical or electrical chip companies and the cable manufacturers to build a solution. So but we would try and have that sort of make the standard as standard as possible, so everybody that's making an active knows the format that they need to fit into it. You know, a bit like a PCI card, but very miniature.
Right. Yep.
So that's the sort of the overall vision. So Mick, how do you feel you would like to play this based on everything we've just said at your end?
Well, I mean, parts of what you've mentioned are relatively easy, right? Like making a connector that's surface mount is something we do on a daily basis, right? So, you know, that part, you know, is pretty trivial. So, you know, something like that, you know, might be something that we could work on.
Yeah, so I mean, there's a couple of possibilities. We need the cables some cables to. This is all POC, right?
Yeah.
So if we worked on the, you know, if Amphenol took the lead on the MCIO, let's say, for sake of argument, they put the mechanical drawings together, and you guys were involved in reviewing it, and you know, from a, you know, everyone can make it sort of thing, and then maybe you took on the, we'll make a cable, Amphenol will work on the interconnect on the board or whatever.
Yeah.
And you know, in the POC is putting the two pieces together. So you get a piece of the funding, they get a piece of the funding. Or you know, or they do everything on the MCIO and you do everything on the EDSFF. Could be another approach. But you work together for some commonalities like this thermal interface.
Yeah. Yeah. I mean, I think all that's, you know, definitely an option. I mean, you know, certainly willing to help, and, you know, either way. And, you know, we could, you know, I know Z very well, so I mean, we could definitely work together, but, you know, I also don't know, you know, how much Samtech or, you know, TE or anybody else wants to get involved too. So I guess we'll just have to.
Yeah, well, like I say, Samtech said they'd be happy to get involved, but I got a funny feeling this may not. Well, certainly this MCIO isn't, because they didn't even make that one. So I unless Matt's not on to stay his position, but they might be able to help out on the EDSFF. I know they do make those.
Yeah.
They may be able to help out on other areas. And again, it's I guess it's like it you know, we don't want to dilute it too much. So whatever makes sense there.
I mean, that's what we do, is we specialize in making custom stuff from the standards. So, you know,
Okay.
So whatever, you know, whatever route we take, and whoever wants to take what, you know, we're certainly willing to help participate.
All right. Well, I mean, okay. So if you're where the approval of, do you contribute to the proposal, or if you need further approvals internally, that would be great. But we're going to need to get rolling on, you know, sort of probably as early as next week on getting the content of this in the spec. So I think the proposal just needs to be, we probably need a little bit more. We just need to flush out the tasks required to get this to a POC level, and articulate that maybe with some pictures, some examples of what we think we need to do, and so that the contracts manager, the procurement manager, can get an understanding of, if they spend the money in this particular part of it, then they're going to get this value back.
So you need like a first draft kind of rough model. I specify a super rough, kind of like what you did, but just kind of like a rough, you know, idea.
Yeah, and what Z did, and maybe working with Z, and yeah. So it's I think the key message, and I can contribute a little bit. I'm going to be spread pretty thinly myself, but the key thing is that we're trying to get this as a universal interconnect. I think that's the key, that bridges all these different worlds of protocols, and so we make this a very modular Lego brick type implementation. You know, and there's a lot of the system management aspects that make sure that, you know, if you plugged in this cable between two modules, in one end was NVLink and the other end was CXL, the system would say, you know, you wouldn't damage anything, but because they're similar PHYs, but basically the system would say, you've wired these two together, they're not compatible protocols, I'm not going to boot. And so, you know, it's a case of that they're recognized there. But we have this very universal ability to wire everything to everything.
Okay.
The idea.
Did you, I didn't look at your website, I'm sorry, but did you send off like your concept models and
So if you go back, it's on the OCP website. My company is just Nalisway, it's just me, a consultant. So this is all volunteer work that I do. So at the moment, I have no way of getting paid in any of this. But that's another problem, but there. Yeah, so but the OCP HPC website, we actually did to this, the precursor to this RFP was an RFI. And we did put as a group, we put in a proposal. So I can, if you go in there, you will see in the wiki, if you know where the OCP HPC wiki, if you just search for that, you'll find it. In the very introductory paragraph there, I think the DOE response that we put in August 22 is there, so you can have a read of what we said there.
but you don't have a picture of this top left concept model with the cable in there at all, or?
This one here.
Yeah.
Yeah, no, we do have the full model for sure. Yeah, I've done a full model of the entire module. Yeah, and we've actually done some 3D prints that we showed off at Supercomputing and
Okay.
OCP Summit.
So would you be willing to give that model out?
Yeah, no, I've already shared. I think it might even be available in the OCP Google Drive. But yeah, no, I can share the entire model.
Okay.
Again, remember it's a concept model, and I'm not a mechanical engineer, so. I've grabbed the mechanical components from somebody's website, like Amphenol or TE, to make the model. So yeah.
Okay. Yeah, we could definitely take a look and give a couple of concepts.
I think well, it's a case of there's a balance of, I don't want to put you off on a getting into the weeds, because you're getting into the work that needs to be done, right? So but in the proposal, we've just got to articulate something that will give people and the government an idea of this universal interconnect could do all of these things with all of these protocols in optical or electrical, co-packaged or near package with inactive cables and all of that. I think that's what we've got. That's a message we need to get across as to why, because they might just say, well, this is just another interconnect, but we're trying to make an open standard that's universal.
Okay.
So yeah, I'll attempt to make the get a straw man proposal with empty spaces for others to contribute. So yeah, if you can start to put something in there, well, first of all, if you can get approval that you want to participate in this, and you can contribute to the document, then that'll be great.
Okay. Yeah, definitely.
And I think once we get, once we get people saying yes, we definitely want to be active in this, and then it's getting those people, back in on these calls, probably trying to get a more of a rapid clip of getting the document completed. But at the end of the day, I guess somebody that fills out the document first has the first dibs. and if we don't have a populated document, we've got nothing to send into the government. So
yeah. Well, I mean, now's a good time going into Chinese New Year. Usually, you got a couple of weeks off here. So
all right, okay, great. That sounds good. Okay, anything else? We've got 10 minutes left from anybody else. Mitch, at your end, I mean, liquids are a potential consumer of this, right? To a greater or lesser extent, with your active CXL work.
Right. Primarily, liquid would be the fabric manager.
Right. So a fabric manager with the likes of the LTPI interconnect. I mean, so if I think about you, you sort of bridge that world of the system management, like you're saying, the fabric manager and
Right.
and an interconnect here. So like the discovery of an interconnect that's plugged in, and is it talking compatible fabric language protocols? Would be a key part of your software stack, I guess.
Well, once all that's defined, it's sort of the software developers for Matrix, they say once it's done and there's an API, and this is why I'm participating also in the management piece,
Right.
is that conceptually you'll export an API that's through one of the standards, and then they have a hardware provisioning, and I mean that's what Matrix is, hardware provisioning and management down at the bare metal layer.
Right.
And so this is pretty far out in front of them. However, we know that the platforms are all changing. I mean, that's what we keep hearing.
Right.
Away from today, Liquid Matrix is based primarily on a PCI Express expansion chassis.
Right.
And there's good, PCI Express had a good year. And today all the GPUs are PCI Express. So
Right.
we kind of have a unique market. However, that's all changing, and this is sort of on the future, in the future horizon roadmap.
Right.
But we're not so much interested in influencing it, other than if there's something that drastically changes the way systems are looked at, which you might do as far as management goes, then we want to either comprehend it or possibly influence it.
So the key things here, right? I mean, we've got this physical thing which we're dealing with, which you would leverage as well. Like, so Lattice are sort of driving the hardware piece, and I'm saying, I don't have the picture in this particular one. I'm saying that we use LTPI and we get rid of all this load of I2C and DC signals.
Yeah, and we're pretty much indifferent to that. In other words, whatever hardware fabric you come up with, other than we believe it's out of band from the high bandwidth interconnect.
Oh, when you say you believe, that's what you want, or you prefer
yeah, we hate to tell you the truth, we hate to be too I mean that's our opinion.
Yeah, I agree,
so
by the
we're
way.
a little small company, so we're not in the position to stand up and say thou shalt make it out of band.
Right.
Right. Because the bigger entities sort of make those decisions.
Right.
And however, we're closely following and working with this CXL spec, and all the pieces are sort of in play for as what Lattice is looking at and so on, that you have sort of an open BMC management entity that is on each of the nodes. And if a node is subdivided, there's not another BMC. In other words, a node is its separate, in my terms, is power cooling reset domain.
Okay, so I mean, we're sort of bridging into the system management, as you say, but the idea here that I've got is I want to drastically simplify the sideband implementation, and this LTPI seems, or some variant of this LTPI, seems a good way to go.
Yeah.
We've also got the idea of a separate control plane, where your system management could also run across, where we're looking at that. So I'm looking at like free space optics to go across the mesh of modules that we have in the wall. Is another possibility.
Yeah, that's certainly something needs to change, and that's a bold change.
Yeah.
But if you get it working, if it falls into place, that would be great.
Yeah, well, so that's why I'm keeping the LTPI on the cables. So basically the entire machine will get connected in one way or another with LTPI between modules. So you should be able to do a crawl in through the network and discover everything that way at the system management level. But if we could get this control plane going at the same time, then that would be an alternative where we can drop any sidebands on individual cables and just have that separate control plane, or maybe a mix of the two. And so I guess that's where I would like. It sounds like you're really well positioned there, Mitch, on the system management software side that, you know, from a POC perspective, assuming we can get some of this implemented during the POC, you could do some rudimentary framework at a software level to do discovery over these links through the Lattice hardware.
Yeah, we think so. So far, we've done a number of POCs with CXL as it's evolved. We're, you know, going back a couple of years even where there wasn't an API yet. And so our software architecture is that the physical layer that it uses, it can even be a serial port. It has been. And
Right.
just a command line interface instead of a documented API. And they can, so long as they know what it is, you know, you can tell them what the commands are and so on. They can add that into our management stack pretty easily.
Right.
But
Do you
but
think that's something
ultimately,
that would Liquid be interested in? It's probably more on the system management side of the equation, but you think Liquid would be interested in?
oh yeah, that's why I'm attending, and
Okay.
is to keep a pulse on it. And if we got to a POC point where, let's say, and I'm just speaking for Lattice and so on, but let's say that management work group lands on an open BMC, that all the pieces are there, and there's somehow magically that we get a little API from either CXL or whatever, and we have, let's say, whatever kind of fabric. At some point it's probably Ethernet for a control plane, maybe in a POC at a higher level, then Matrix would be well positioned to be able to be the fabric manager or the system manager for that.
Okay, do you see yourself as partaking in this response, or you're sitting in the background and see how this response comes together and then contributing if it comes together?
Well, let's say that first, I absolutely can't allocate resources myself.
No.
And then, of course, we're a small company, and the task of items that they're working on for real customers is pretty
Long.
tall.
Right.
To keep the lights on.
Yeah.
And we have customers. That's always good for a small company.
Yeah.
But if we defined it very well, and it was, you know, consumable, in other words, is bound, wasn't open-ended, then you know, I could pitch it. However, I think for this response, I'm not sure. We'd have to figure it out quickly, you know, how to bound it into a form where they would.
Okay, look, hey, Mitch, we're at the top of the hour, but hey, Mitch,
Yeah.
I truly value your input. And by the way, thank you very much for your support on the system call that I didn't manage to attend.
Yeah, so let's pick it up. Let's pick it up then, maybe.
Yeah,
Okay.
but just to say that obviously you being here, you've got a good system level eye and in different ways to me on various aspects, especially in this area. And so maybe just if you're not participating directly as a company, but if you can keep us all honest on all the pieces coming together, if there's missing pieces in your mind,
Yeah.
then
And I'm actually quite interested in the interconnect,
Right.
you know, historically. So
Okay.
That's our role.
All right, thanks. That's great. Well, thank you very much. Thanks everybody for the call. Yeah, so Bobby and Well, we've lost everybody now. But if you guys, you know, if you can just chase up internally, we just need to know, or we just, you know, when we get this proposal going in the next few days or next week, we're going to need sort of people to get pen to paper. And so if you can find out pretty quickly if you're willing to be part of this or not, that would be great.
Yeah, for sure.
All right. Thank you very much.
Yep, take it
Okay.
on.
Have a good day.
Thank
Sure.
you. Bye.
Bye.